Hello, everybody. Matthew Jacobs with Ohio Weather Specialist coming to you with the current severe weather event. Now is the perfect time to show you how to read radar and use the different products to spot tornadoes during severe weather events. As you can see, this is your base reflectivity. This is what you will see on most news stations and like your local news, as well as Weather Channel most of the time. This is how they'll show you where the rain and precipitation and stuff is coming from. I'm going to show you a couple ways how to be able to spot a possible tornado or rotation with the base reflectivity. As you can see, we will go back. And you can see by this point there was already tornadoes reported on the ground. And as you can see, it's very difficult to decipher where a tornado might be in this graph. But as you can see right here, there is it looks like a comma. If there was a reported tornado, so we know it's on the ground. It would be right in here. And another perfect way to decipher a tornado on base reflectivity is with this little donut hole right here. They call it the donut hole. That is strong indication that there is a tornado on radar. As you can see, this part of or this supercell here, this is what we were talking about the other day, the eagle shaped supercell or thunderstorm. And usually, if there's a tornado associated with these storms, they will be right in this area here. And I will show you another product here called the base velocity that will make it a lot clearer as to where there might be tornadoes on the ground. So as you can see, there's red and green on the tornado. As you can see, here is our radar site right here. Reds are pushing out away from, and reds are going into, like toward the radar and away from the radar. So what that means is it measures the wind coming into and away from the radar. And where we can spot tornadoes or rotation on radar, it's where these reds and these greens touch. And the brighter the red, the brighter the green, the more likely that you are looking at a tornado in progress, or at least a funnel cloud. And we will move this forward. You can still see the reds and the greens touching. And now it gets more defined here, as you can see the greens and the reds kind of, it looks like they're almost circling each other at this point or circling around each other. Your tornado is definitely right in there. As you can see, the bright green and the bright red touching each other. That tornado is right in that general area. And you can actually see the rotation on radar. You can see how this green is kind of wrapping around like that. Go to the next, and it's still there. Not quite as well defined. Let me go back one. I apologize. And your rotation is going to be in this general area right here. And now you can see that it's starting to weaken a little bit. But this storm was actually cycling. And now we still have rotation right in this area here. And once again, there you have the greens and the reds. Still there. Still there. So, and as it moved on, it weakened and pushed uh, outward. But this cell back here has now kind of become the dominant cell, which happens very often in supercell thunderstorms. At one point in time, it did appear like this tornado or this supercell was going to possibly produce a tornado as well. There's still one tornado reported on the ground right now, but we are now going to show you a different product. Sorry about that. Actually, opened another radar program. Your NROT, which shows your rotation. So let's go back to when that cell was being reported on the ground over here. Let me zoom in for you. And as you can see, the rotation chart goes up to 3, and it is that white color right there, which means it had the strongest level of rotation it possibly could have, which means that this time, if that tornado was not on the ground, it is it is a funnel cloud ready to touch down. As you can see, rotation is strong there, and this is the first radar image I have. But by the time it gets to here, that is a tornado on the ground, folks. That is what you're looking at right there. And then just to corroborate that, these reds and blues and greens indicate some sort of clutter in the radar, and that is often defined on radar when you have debris from a tornado being lifted into the sky. So what radar does, and your radar's here, it sends out a beam, and a lot of times you see this right here. That is radar clutter. That is not actual debris here. Anyway, to go back, it sends a pulse out from the radar. So here's our radar location. It comes out, and anytime it hits something, it will push the beam back, and the radar will read that. So, like on your base reflectivity with rain, your radar pushes it out, brings back, and it can detect all the hail, rain, and debris in the air. Now, going back to our correlation coefficient, we know how to determine the difference between false readings and normal readings, because if we go to base velocity, once again, we see that there was a tornado reported on the ground, and we see the rotation still on the ground. So if we come here, you can see a little bit of debris within and near where that tornado was reported. And if you go here, you see a little bit more. And then these next two debris signatures will really kind of put it into perspective. Our heaviest rotation here is defined by this triangle, and you see there the red, the greens and the blues, and then right there, which means there was a lot of debris being picked up by radar. And by debris, doesn't necessarily mean homes and cars and stuff like that. It could be dirt, dust, and all that kind of stuff as well. So it's any kind of abnormal readings that the radar detects. So like I said, since I had a moment to come on and get a video of tornadoes in progress and how to read them on radar, I wanted to give you the tools so next time you're watching your local news or you're watching the Weather Channel or whatever way you prefer to get your weather, I just wanted to give you the knowledge so you had a little bit better understanding and idea of when they're talking about things on radar, you would have a better understanding of it. Once again, just to quickly recap, you see your comma or your hook echo is the actual term, your inflow notch, and then you see your outflow pushing back here. Your hail is defined by these lavender colors here. Heavy rain is the red, lighter rain is your green, and your blue, yellows. So, um, yeah. So, like I said, I just wanted to get a video up here so we could teach you a little bit of how to read rotation and possible tornadoes, and in this case, actual reported tornadoes during severe weather. And so you can have a better idea of what to look for on radar during severe weather days in your area. Once again, I'm Matthew Jacobs with Ohio Weather Specialist. Thanks for tuning in. Have a great day.